Good morning, mathematicians. Yeah, what kind of math are we going to do today? What kind of math were we doing yesterday? I don't remember. So we're free. We're free of the burdens of yesterday to choose our own destiny today. Remember that. I guess we could go back to archive. See what's happening there. You're having ChatGPT research running in the background, like baking a cake. Nice. Nice, a big data cake. What could be better? The most nutritious meal of the day. ChatGPT rendered data. Let's see if any Leyland's news is popping off. Aristotle results? Hello, Matthias. What do you mean by Aristotle results? Is this a math LLM? Is it this? Oh, I saw something about this. Apparently, if you're talking about this result, it didn't actually prove an unsolved problem. Yeah, as said. Well, I don't know. I didn't look more deeply into it. But according to other people, according to this top comment, it didn't solve the problem. The guy who runs the website made a mistake in the statement that makes the problem very easy, and the AI solved the easy version in a few hours. It's a complete nothing burger. Oh, actually, this one says that's not correct, though. Aristotle solved a version of the conjecture that was written by Erdős himself. It does seem to me Erdős did not realize that it changed the nature of the conjecture. Okay. Where's the original article? It's been deleted. Why did this person delete it? Pure motives are not meant to represent cohomology theories, but only that the functor factors through them. Ah, interesting. The functor factors through them. Okay. Wait, what functor? What functor? So a pure motive should be a functor, and that functor should factor through a cohomology theory. Well, 2 to 3 weeks is a lot of time to prepare for your exam, Matthias. So, work hard, I guess. Good morning, Ken. To actually make them representable, you have to go to the triangulated category of mixed motives, which is analogous to the transition from spaces to spectra. Is that what people are doing these days, though? I thought everyone hated triangulated categories now because you can't take limits, and so everything's an infinity category instead. The functor is, I see. Oh, you're saying H is the functor of homology, and you're saying the homology factors through motives? I don't understand. As far as you know, it's a real solution. Now people are saying yes, but weren't looking at those Erdős problems. There's 100. Yeah. It's kind of goalpost shifting. Where's the article, though? Because this person... Why did they delete this? Maybe because they thought they were getting ratioed by the first comment? Let's see. I don't know. Let's click on this one. We finally got a paper into the rep theory section in archive. Hell yeah. Hell yeah. Are you going to let us know what it is so we can go take a look? Or maybe you don't want to dox yourself. Cohomology as a factor is okay, as a composite through that. Okay. Good to know. My thank you for absolving my dissolving my misconception. I do have X. Well, what's the title of the paper, Ken? Do you want to just tell us the title of the paper? Oh yeah. Okay, there's a link to the tweets. Or what are they called if they're not called tweets anymore? X's? Treasures? Because X marks the spot? I don't know. There was no human. Okay, let's see what Terry Tao had to say about it. The Erdish problem site, which currently hosts 1108 problems that were stated in at least one paper of Erdish, is also of this nature. Oh, isn't he? Okay. A few weeks ago, nearly a dozen problems that had been classified as open on the site became resolved after AI power literature searches turned up solutions. Okay. That is different. I also heard about something like this happening, but yes, so this is different, right? I think this happened. This is an even older one, right? When's this Mastodon thing from? This is an even older one, right? Because it's I mean, okay, still useful. Still, it's something that we didn't collectively thought was proved, but yeah, I mean, it just found existing proofs. That's all it did. Recently, yet another. Okay, maybe this. Specifically, problem 124 was a problem that was stated in 3 separate papers of Erdős, but in 2 of them he omitted a key hypothesis, which made the problem a consequence of a known result. However, this fact was not noticed. Okay, so is this this is the most recent one? Then, yeah, I don't know. To me, that really doesn't sound like. To me, that really doesn't sound like the way that the headlines frame it. If I want a job, learn the Levenberg Marquardt algorithm. You can't post links in chat, but you can tell us the title of the paper. Unless I give more people the gear icon, but I feel like it's a special status. But if I'm searching, well, I mean, maybe I do need a job. I did just I got my first postdoc rejection this morning. I'm not going to Sweden for proof assistance. Which, like, maybe that was the least likely one to get into anyways, but it would have been a cool excuse to pivot to proof assistance. Olivier curvature of random geometric graphs converges to Ricci curvature of the Riemannian manifold. Oh, that's the you want to this is a paper that you want us to discuss, and so we shall, Ken. So we shall. Oh, did Arad link that already? Oh, well, we got okay. Thanks anyways, Arad. Thanks anyways. Stated skeins and DAHAs. Nice. Boom. Got it. K-Theory tries his best to get closer to you. I mean, there's still hope. There's still my application in Spain. So Not quite as close, I suppose, but yeah. None of the other places I applied are that close to you, though, Nikolai. So I haven't been doing a good job. As for the AI thing, as you say, there's things going on, and people are gradually adjusting their expectations. It will scoop us up one cope at a time. Yeah, yeah. I mean, I don't mean to completely poo-poo. I mean, this is still, you know, like clearly it has helped clarify things in a non-trivial way. Clearly, it has helped um, uh, clarify things in a non-trivial way. However, there is inaccurate reporting going on, right? It's a classic thing that's been happening forever now. Sensationalist headlines, and then people just read the headlines, and then they just repeat the information, and then it's like when you open up the article, you find, oh no, it's not exactly as how the headline had called it. I don't think it will be long before. I don't think it'll be too long before these headlines that are currently sensationalist start to become accurate. Although, when those things start happening, then of course it will be, you know, it will be described with an even more sensationalist headline, undoubtedly. And it absolutely will not stop ever until you're dead. 1984. What's it? What's that from? What's that from? What's that from? It's familiar, but I don't know. I can't think of the film off the top of my head. Uh, it's from a movie, right? Um, Ken, you wanted me to pull up this paper. Oh, it's from Terminator. I should have guessed. I should have guessed. That's 100% on me. Curvature is a fundamental geometric characteristic of smooth spaces. In recent years, different notions of curvature have been developed for combinatorial discrete objects such as graphs. However, connections here we prove that random geometric graphs and manifolds converge to the Ricci curvature. Cool. That makes sense. One would want such a thing to be true. Yeah, no, Ken, do you have you just think it's cool you can define graph curvature in a way where the curvature of a random graph sampled from a manifold converges to the curvature of the manifold. Yeah. Yeah, seems cool. I wonder if they did stuff about like statistical estimates, like something about like the rate of convergence. So, graphs of over maybe it'd be too hard to compute. Or you could get bounds, I guess, like, say start with a graph of 3 vertices. Okay, how close can the curvature possibly be? Well, I guess a very crude bound would just be you look at as you let n increase, right? You let the graph get finer. I guess the crudest upper bound would just be like, yeah, the curvature of the graph. But I wonder if there's some way that you can control the deviation more. I mean, probably, right? Yeah, because probably I don't totally understand what's going on here, but probably they do some argument that says, well, you know, if you have a graph, you know what the curvature is, you can probably like create a new graph. You add a new vertex and some edges, in such a way, that brings it closer to the curvature. This is pretty out of my element though, so I don't know. I don't know how much more stuff to say here. Hello, Kostaka Corey. So I'm gonna go check over the from our guitar playing friend, our guitar resident guitar freak, unstated skeins and DAHAs. I don't know what a stated skein is. A skein module is an invariant of an oriented 3-manifold. I was just looking up at some stuff about the analogy of knots and primes. And I wonder, is there an analog of skein module in knots and primes? I wonder. Module over a commutative ring with an invertible element. Well, this looks extremely Hecke algebra-ish. And these modules generalize polynomial invariance of knots and links. Okay, 100%, this has to have an analog then in arithmetic topology. As an R module, they're spanned by framed links. In some versions, the links are decorated with some representation theoretic data. Typically, the skein module of R3 is isomorphic to R itself, and under this isomorphism, a link is sent to its polynomial invariant. There are many versions of polynomial invariants, and these typically correspond to a specific version of skein module. For example, the Jones polynomial of a knot is equal to its class. Hello, Tenacity and Leo. We're looking at a recent paper from a chatter. Okay, hang on. I need to process this for a second. New versions of polynomial invariants, and they should correspond to a module. So the Jones polynomial is equal to a class. Wait, this class is somehow represented by a polynomial. The Jones polynomial of a knot is equal to the class in the Kaufman bracket skein module. I don't understand this. But I guess maybe the module is some sort of polynomial algebra or something. I don't know. I don't know if a Freak Guitar Official, you can if you understand what I'm misunderstanding, and yeah. Anywho, skein module is functorial from oriented manifolds, and this converts additional structure on 3-manifold. When you put the knot in R3, the knot simplifies to a polynomial of Q. What? How does a knot simplify? I mean, I get the idea of attaching a Jones polynomial, but what do you mean by simplifies to? What do you mean by simplifies to a polynomial? You just mean you're attaching the Jones, like you can describe the knot with a Jones polynomial, right? That's fine, but I don't understand how can a knot be equal to the how can a knot be equal to a class? Okay, go to the next page. I see. Oh, okay. So somehow you have a polynomial with coefficients, a polynomial in Q with coefficients in knots? How do you make this formal, though? How do you make this formal? So it's somehow... okay, so somehow it's like spans, the module has elements which are knots. But they're, yeah, interesting. Let LM be the free R module with basis the set of ambient isotopy classes. Okay. So it's right, the module, it's a span of isotopy classes of knots. Okay. Okay. I see. Free R module. Wait, is Q is an element of R? Is this the case? Q is an invertible element of R? And R is commutative. Right, yeah, okay, yeah. And I see Q is in there. Yeah, I see. Okay. Interesting. So, gonna take a summer course on lean. Gonna take on summer course on lean. Well, I would have joined you, but now I'm not going to Sweden. This comes from category theory. The diagrams have structure which look like knot theory. So each picture corresponds to a morphism, and you see the relations via these pictures. Maybe I don't understand what isotopy means, but I would have thought that these two, I can't even highlight them, but I would have thought that these two would be the same because they look like they're just rotations of each other. But maybe I'm not interpreting this diagram correctly. Yeah, I'm probably not interpreting the diagram correctly. Then you'll be able to formalize your trash proofs. Yeah. Well, I may do some lean learning on this channel, eventually. Anyways, just cause, you know. Maybe some evening office hours where I try to teach myself some lean. Yeah. How about doing some skiing in lean? Why not program a skiing in a lean? Well, I listen to Julian Bream. They're not the same. Different lengths on outside four edges. That L prime is what you quotient out by. Quotient out by. Oh, I see. L prime. L prime is the smallest module containing these expressions. So the vertical diagram corresponds to an identity morphism on a tensor product, and the horizontal one corresponds to evaluation and co-evaluation. Wait, tensor product of what? On the module? And co-evaluation, evaluation of what? But I mean, these pictures are supposed to be isotopy classes of knots, right? What's an R matrix? Oh, lowercase r matrix maybe meant uppercase R matrix? Is it a matrix with values in R? No, I don't understand what's going on. I thought these pictures are supposed to be isotopy classes of knots. I'm very confused. Yeah, I mean, it seems interesting, but perhaps this is too far out of my element here. Although I do want to read something about what this how the DAHAs get into here. Turns out in many interesting cases, algebras and modules constructed by skein theory are closely related to double affine Heck algebras studied in representation theory. Prove things in combinatorics. The DAHA given by this thing is an algebra. DAHA is double affine Heck algebra. So QT, what's the frac G here though? Oh, it's because that's the Lie algebra it's attached to, right? Okay, it's an algebra over that. And specialization, right, is just a group algebra of that. The T parameter deforms the Val group, and the Q parameter deforms the Laurent polynomial ring into a quantum torus. What the hell is a quantum torus? Long story short, if you do this on a punctured torus, would do what on a punctured torus? Hello, Daniel. Do what on a punctured torus? Is Merida equivalent to the SL2 Daha? Wait, what's Merida equivalent to the SL2 Daha? The corresponding scheme module? Okay, maybe this is explained down below. Remarkably, both of these deformations can be made simultaneously, and this is flat over this. The goal of the present paper is to study some relationships between stated skein theory and DAHAs in the case of G equals SL2. The skein algebra relations, the algebra. Okay, I see. So the skein algebra is Merida equivalent to the SL2 Daha. Interesting. And that's one of the results in your paper. I guess conjecturally this should hold more generally. Or do we know in greater generality yet if the Dahas are Merida equivalent to skein things? Well, as it said, the goal of this paper is to study relationships between skein theory and Dahas, Leo. And then you come up with new modules and representations for Dahas via these skein things. I see. Very roughly in this case, the relationship between stated skein theory, and the skein theory described above is similar to the relationship between decorated Teichmüller space and Teichmüller space. Well, I know nothing about that, but concretely, the Kaufman bracket skein module is spanned by framed unoriented links, and the stated Kaufman bracket skein module is spanned by framed unoriented tangles where the ends of the tangles are decorated by states. Yeah, this is all beyond me. Yeah. Ooh. The 26-dimensional E-rep of F4 decomposes into 3 E-reps of spin 9 of dimensions 1, 9, and 16. The one-dimensional factor means spin 9 stabilizes a vector in the E-rep, and the decomposition of such a point, and the orbit of such a point must be F4 mod spin 9. What this all means is that F4 mod spin 9, aka the Cayley plane, has a homogeneous embedding into R26. Well, I'm very intrigued by your totally out-of-pocket comment here, Daniel. The Cayley plane being what? That's like the octonionic projective plane? Yes. Projective plane over the octonions. More precisely, as of 2005. Part of me feels like that's recent, but actually the sad truth is that's ancient now. 2005 is literally ancient. There are 2 objects called Cayley planes. The real and complex Cayley plane. Okay, where we take, so one of them is the compact form mod spin 9. That must be what we were talking about. It emits a cell decomposition here. What this all means has an embedding into R26. Where do I read more about this? You know what? I don't even understand the spin groups all that well. Oh, it's just a double cover of SON. Short exact sequence. The group multiplication law is given. Yeah, so how do we describe it? Actually, well, what I guess we have an abelian normal subgroup. So, can you do some group cohomology to describe this? I mean, it should be pairs of elements. Can you describe it as pairs of elements where something it's something in SO and then an element of Z mod 2? Yeah. Oh, there's a more explicit construction here. Links in the torus minus a disk. Links in the torus minus a disk. You see a module over that thing. Well, I think R is an algebra over Z adjoin Q inverse, right? Pre-iPhone era, yeah. Or dawning of the iPhone era, wasn't it? No, when did iPhone come out? Maybe I'm thinking about like iPod Touch or something. You used to be an exception Leo group. Skene modules only work on 3 manifolds, but if we want to use a surface, we actually use the thickened version of the surface, so it's a 3 manifold. Oh, okay. An algebra structure is given by stacking. Is that why? I know there's something where like you consider like the tubular region of a knot. No, that's probably not why, but maybe that is somehow related, right? I know in knot theory, right, when you define the knot group, don't you take, because it's an embedded S1, but then don't you like infinitesimally thicken it so now it's like a 3 manifold or something, and then you look at the fundamental group of the complement. That means something in there. You saw some paper where a guy cited Teichmuller, and the footnote read something like, not because a work delights is the author to be praised, nor because it pleases is he to be approved. Yeah, okay. Is this thickening just product with 0, 1? Oh, yeah. Okay, so maybe it's not quite infinitesimal. Well, Guitar Freak, it sounds like you got to make some YouTube videos then, explaining how it works and making some drawings. Oh, I see. Right. Okay, cool. So you get a module for each knot from that. Cool. Cool. Maybe this is too crazy, but then do like... Or they're like operations on knots correspond to operations on modules. Like if you take some sum of knots or something, does that correspond to a sum of modules? Or like does tensor product mean something in that case? Q is a quadratic form. Right. Right. The resulting space is naturally graded. Wait, what's it graded by? Where n is the dimension of V. This is this. This is this. Wait, how is it naturally graded? I guess I gotta learn Clifford algebras. The spin algebra, spin, is defined as the bivector subalgebra. Okay, so it's just the second graded piece. What's a grading, though? I mean, I'm tempted to say it comes from the tensor powers, but doesn't this relation kill all the higher tensor powers? Shouldn't there not be a CL2? Like, am I crazy? Oh, no, it just kills the self. Sorry, it just kills the self tensors. I see. Right. Okay. So I see. It's just the I see. So it comes from the n tensor component. Gotcha. Okay, that makes sense. Getting naughty. So when I say we come up with modules, it's because the boundary of these knot complements is a torus. So the tori, it's the fact that you get a torus that gives you a module over a DAHA. Interesting. You're late thanks to uni internet. Yeah. At my university, the internet frequently goes down. Maybe not frequently, but not infrequently. You hope one day that I solve the Collatz conjecture. I hope not. I hope not, because I'm not even trying. And so, if I somehow solved it by accident, I don't know. The world would be too weird. You got to learn Clifford algebras and K-theory already. Yeah, that's true. I got to learn a lot of stuff in K-theory already. Yes, yeah, kills, yeah, self powers. Yeah. Yeah, maybe I probably should have scrolled through to see more of the pretty pictures. Probably should have showed off more pretty pictures here. Ooh, the trivial knot relation. Yeah. You get to unleash your inner geometric algebra enjoyer now. What exactly are we doing? Well, what were we doing? I think we were trying. Really, I wanted to. Well, there was this claim. From Daniel about the Cayley plane and understanding it as an embedding of F4. Actually, there's something about maybe we'll look at this tomorrow. I think I'm gonna go soon, but I think there's a recent paper. Is it this? My supervisor was telling me. No, I thought My supervisor is telling me there's a recent paper by Barcini that computes some A packets for p-adic F4. Um, so it should be here. What if I search archive? F4. No, that's not going to help me. What if I just search Barcini? I was pretty sure he said it was from Letitia Barcini. Micro packets for real groups of G2. No, that's not it. Huh? Let me take a look at this, but that's not there. Maybe. Oh, was he just talking about this older paper? Was he just. Wait a second. Wait, when's this paper from? 2018? No. What? Was he just talking about this paper? Cuz this is old news. This is old news to me. I mean, it's still new and exciting, generally speaking, but let's see. Because I think they talk about F4 in this paper, but they're like, yeah, let's see. G be simple of type F4. P is maximal parabolic. The upset nil radical. But we've already remarked that this properly contains this. Thus, there is no choice of P. Yeah, so they say something about the method that they outline in this paper doesn't work for F4. I don't know what else. A packets for p-adic F4. Let's see if that brings up anything. No. Huh? What was my supervisor talking about? Well, maybe I should go and ask him. Oh, wait a second. The dual pair aught C times P4 p-adic case? What? Huh? Huh? Oh, and what's this? Something from Atobe? Maybe this is something I want to be looking at. There's a lot of stuff. Yeah, those definitely look like difficult TIX images to make. How do we go from knot theory to Clifford algebras? Because of a random comment in chat. That's how. The same reason we do anything. Is this maybe what my supervisor is talking about? Aught C times F4. We studied the local theta correspondence of the form aught C times F4. Okay, no, this is theta correspondence stuff, which is maybe interesting, but I don't think there's nothing about A packets here. What's happening in Atobe's paper? How about this? Chat, should I stream after K and go over proof of G compact implies rep G semi-simple? Yeah, do it. Do it. Yeah. I know I said I was about to go, but I'm trying to read this, and I'd be reading this anyways. The purpose is to explain the ABV packets constructed in here. From Atobe. Okay. Interesting. Now, what is meant by explain here? Explain the connection to the original definition? Okay, well, no, I'm not gonna stall for 5 minutes. I'm gonna peace out now. So, and read this paper with greater concentration. So, peace out, y'all. I'll see you tomorrow probably, and